In this video, we're looking at modulus and argument. So when you draw a complex number like this, the modulus is the length from the origin out to that complex number. So that length there in red. The argument is going to be the angle that it makes with the real axis in blue. So if you're making a positive angle up here, you're going to get a positive argument. But if you have a complex number down here, you'll make this angle and get a negative argument. Let's have a look. So we'll do modulus first, and the formula is here. You do the real bit squared, and you do the imaginary bit squared. Add them together and take the square root. Hopefully this looks similar to Pythagoras since, well, it basically is Pythagoras since we're finding a length. Let's do an example. So 3 plus 4i, we're going to get a equals 3, b equals 4. So z equals root of 3 squared plus 4 squared, which is root of 25, which is 5. So here's 3, here's 4, here's the number. And what we're basically saying is the length of that line is 5 units. Hopefully you agree. All right, we got z equals 1 take I. So here's 1, here's minus 1. We got our number there. We want to find the length of this blue line. Pythagoras. So square root of 1 squared plus minus 1 squared. Now you have to be really careful. The number with the I is minus 1, so that's why minus 1 goes there. A very common mistake is that people put I in these brackets, and that will give you the wrong answer. So it's just a number with I. A is 1, B is minus 1. Those are the numbers you put in. So 1 plus 1, which is a root of 2. You can get an approximate, 1.414, but generally root of 2 is preferred. All right, z equals minus 1. Minus 1, so we want to find the length of that black line. Pretty clearly it's 1, but let's make sure we get the right answer from the formula. A equals minus 1, B equals 0, because this is minus 1 plus 0i. So you're going to get root of minus 1 squared plus 0 squared, which is root of 1 plus 0, which is root of 1, which is 1. That's great. So we know the length of that line is 1. Now, if you're familiar with modulus, absolute value signs, you'll know that they behave like this. It just flips all the numbers positive. And it turns out modulus is just kind of the extension or generalization of absolute value. So it's still true that the modulus of minus 1 was 1. And that also works out if you use the modulus formula, which we should hope for. We'll learn more about absolute values next topic as well. So next we've got argument. So I'm going to bump up my scale a bit here, so we can see really clearly. I got this complex number up here, and the argument is basically going to be the angle in there. Now hopefully you can see that's 45 degrees or pi over 4. If we're in radians, pi over 4 is preferred. Let's see why exactly. So the argument formula, basically what you want to do is you want to inverse tan the imaginary bit over the real bit. So let's do that. So argument of z equals inverse tan. Now the imaginary bit was 1 and the real bit was 1. So that's going to be 1 over 1. It's inverse tan of 1, which if you use your trig table, we should be able to find. I've got tan of 1 here, and the angle is pi over 4. So if you're not sure about this, grab your calculator. Make sure you're in radians. On a Texas, for example, radians will be in the mode button here. Then you want to use inverse tan of 1, and you'll get that answer, 0.785. And then if you do pi over 4, you'll also get 0.785, so we're nearly correct. Now this works all well and good when we're in the top right quadrant, but when we go to another quadrant, it can get a bit messy. So here's 1. Here's minus 1. So it's basically the same complex number, but we flipped it down. Now we knew from our example before that this angle was pi over 4, and the other angle is pretty much just the mirror image. So it's negative pi over 4 down here. Goes the other way. All right, next one we have is minus 1 plus I, so we're up here. Now again, the mirror image we had was pi over 4. And then that means this angle in here is pi over 4. So let's have a think about this. If I go all the way out to pi in that red there, and then I want to take it back pi over 4. So I'd do pi minus pi over 4 would give me the angle that I want, which is 3 pi over 4. And that's basically just this black bit here, 3 pi over 4. That is my argument. Next one, minus 1 take I. So what you'd probably be tempted to do here is go all the way out to pi and then add on another pi over 4 and you'd get 5 pi over 4. That is technically correct as an angle, but it's not correct as an argument because arguments can't be bigger than pi. So 5 pi over 4 is not what we want. Let's see how we actually get this. So we kind of draw the equivalent angle we found before, pi over 4. And that means this angle here is pi over 4. If we go all the way out here, that red angle equals minus pi, and then the blue angle equals pi over 4. Add them together, let's see what we get. Which is going to be minus 3 pi over 4. So this black angle here is minus 3 pi over 4, and that is the argument of z. See how that's in between minus pi and pi? That's exactly what we want. And the reason you do it in between minus pi and pi is because that gives you a complete circle. So you get the top half if you go up to pi, and you get the bottom half if you go down to minus pi. Now it pretty much gives you the complete circle, but what about this point here? It looks like it overlaps, but that's why the argument of z is less than or equal to pi, but it's strictly bigger than minus pi. So in fact, that point that you get on the edge there, you need to make sure that if you get a point that's here, it has an argument of pi, not minus pi. All right, great. Now, if you're really freaking out about this stuff, I do have an explicit formula. I'd prefer it if you didn't use this, but look, it's there if you need it. So what we were basically doing there is we were calculating this number, which I've called phi, and you get that from inverse tanning. In our case, phi was pi over 4 for those last 4 questions we did. So if it's up here, you just keep that number, you're all good. If it's down here, you make that number negative, which I believe we did. So if I scroll back down to this example, our number was in the bottom right, so I just took negative pi over 4. Next example we did was I did pi minus whatever that number was, and that's why in this formula up here, I've written pi minus whatever phi was. In that case, it was pi over 4. Similarly, in the last bit, I've written minus pi plus phi, and that was basically what I did there. So if we go back to the example, I did minus pi plus that number. All right, next, z equals 3 plus 4i. We need to find the argument of z. 1, 2, 3, 4. Here we go. And we're looking for that angle. So a is 3, b is 4, and argument of z is going to be inverse tan 4 over 3. Now try all you want, you won't find 4 over 3 on your trig table. So we're going to have to do this approximately. Inverse tan of 4 over 3. Make sure your calculator is in radians. 0.927. And we put a little c up there to show we're in radians. Great. So what would we do if we had minus 3 take 4i? Well, we'd be here and here. From the last question we did, we knew that this angle in here is going to be 0.927. So argument of z means we go all the way out to pi, the whole way. So minus pi plus 0.927. And let's figure out what that is. And we'll just add on our answer from before. Minus 2.214. Got to have a squiggly equal sign because we did approximate. And that is our argument there. What we measured is the angle out to that red line, minus 2.214 radians, and it's minus because we're going clockwise.